Am I audible?
Yes, ma'am.
Yes. Thank you, students. Is first batch is ready? So warm welcome to Mohana ma'am. So we are going to organize this Make-a-thon and Codathon, Make and Codathon 2020 in association with Scope and SAS. So we have Mohana ma'am here, and let our students start the presentation. Who is going to start first? You want me to take it and read it out? Vishwak and Sudhir team is available. Vishwak and Sudhir team?
No, ma'am, they are not available.
Okay, Naveen Kumar. Lavan Kumar team, if your team is ready, we can start then.
Ma'am, wait a minute. Our teammate is now only joining in network.
Okay.
5 minutes, ma'am.
Tejashvi. Kavi Arasan.
Ma'am.
Kavi Arasan. Who's that?
Ma'am, Sudhir and Vishwak team.
Sudhir, your team is ready, ma'am?
Yes, ma'am. Myself, I'm ready, ma'am.
You just start presenting it, okay?
Ma'am, my teammate is not here, actually.
You just get ready with your content.
Okay. Ma'am, everything is ready, ma'am, actually. Now.
Okay. So we are going to have a different exposure here now. So you'll be presenting your work here, all your demo, your simulation, everything has to be projected here. And here we have a reward of awarding the best or the most nominated team. So you can ask your team members or you can ask your friends to nominate yourself. So whoever is going to get the good voting number, you will be awarded in one category called the most nominated category. You just 5 teams will be available with us. The rest of the team you can join in our live stream and you can start posting your voting in this live stream. So I'll be counting all the voting from the streams, comment or your chat box. Sudhir, you start. Sudhir, let Vishwak join with you if you have the content.
Okay, yes, ma'am. Ma'am, shall I share my screen, ma'am?
Yes, you share your screen. I will stop my sharing.
Ma'am, can you able to see my screen, ma'am?
Not yet, Sudhir.
Actually, just presented. Now it is available, ma'am.
Yes, it is about to start.
Ma'am, can you able to see my screen, ma'am? No.
Your PP presentation is not visible.
Ma'am, my screen is visible, right?
Yes, your screen is visible.
Okay. Okay, that's okay. That's what I'm asking. Good afternoon, ma'am. Myself is Sudhir, and my teammate is Vishwak, and our project is lane detection. It is based on IoT, ma'am. And lane detection is a critical component for self-driving, ma'am. And identifying lanes for roads and is a very common task that human can perform easily, ma'am. This is important to keep the vehicle in constraints of the lane. And this is also a very critical task for an autonomous vehicle to perform, like to detect the lanes is very common critical task, ma'am. And the main purpose of our project is to reduce accidents, and we're proposing that to increasing the safety and saving the human lives. Human life. Our concept is used to describe the path for self-driving or and to avoid risk of getting in another lane. The process is to detect avoid the risk of getting in another lane, and the process is to detect the lane lines in the real time process, ma'am. Ma'am, shall I show my implementation, ma'am?
Yes.
Okay, and I've used one. This is a sample data which I've collected, ma'am, and the data which is in the form of BGR, and this is not in BGR actually. This is after that I've converted into RGB. Here I'm using a two functions, ma'am. One is OpenCV function, and another one is pillar function. So in this case, I'm using two functions so that I have to convert to RGB, ma'am, so that only my data can be visible. So that I'm just first step is I'm converting BGR to RGB.
Sudhir, your coding is not visible now only.
Okay. Now it is visible, ma'am.
Yeah.
This is sample data, ma'am. This is a single frame which is extracted. After that, after converting to RGB, I'm just converting it into HLS, ma'am. HLS is nothing. It is a hue lightness saturation, ma'am. And this process won't make too much difference, but for favorable condition, it is very useful, ma'am. When the road is shaded or white lines are on a concrete road, in this case, if we convert to HLS, it is often results in a such higher contrast between lines and the road, ma'am, which improves the efficiency of carnage detection, which we going to process in later on process, ma'am. So that I'm converting to HLS, and after that. I'm just using a trial and error method, ma'am, to select only the lane part alone, ma'am. So in that case, I'm getting after selecting the after applying trial and error method, I will get the lane part, and after selecting the lane part alone, I have to apply black. I haven't selected, ma'am. So I can get exact view of the lane part. After applying mask, I'm going to convert into grayscale image using the carnage detection, ma'am. Carnage detection, it is an algorithm that detects the edge based on gradient change. It is technique to extract useful structural information from different version objects, and dramatically reduce the amount of data to be processed, ma'am. By using the carnage detection, we get the proper outline of the lane, ma'am. Let me show that. You can able to see the exact view of the lane part alone, ma'am. Up to this is up to carnage detection. That I have improved. I'm going to draw pipeline using a off transform, ma'am. Transform algorithm. Is it visible clearly, ma'am?
Yes, visible.
The same data which I've collected from the before the canvas reduction. After processing canvas reduction, I'm using off transform to drawing the pipeline to detect and displaying the pipeline, ma'am. This is only for single frame which we have processed, ma'am. After that, we have planned for video, like we have collected data like video, and we just process the same thing, ma'am. This is only for white, so which is used for detecting the lanes. Only for white lanes alone, ma'am. And next, the combination with yellow lanes, ma'am, because we have different kinds of lanes in different areas, so that just collect different kinds of data. This is with yellow lines and white lines, ma'am. It's about like challenging one, ma'am. Like when the car is moving in like curved part or in a shaded region or in shadow region. In that way, just process the video. You can see the little deposit of the lane, ma'am. So in that case, we have used frames per second. That each frame by frame it can be processed, ma'am. Serious, ma'am. Like this process is processing for frame by frame, ma'am. Processing the video file frame by frame, ma'am. We'll be keeping the record of the time when the last frame is processed and the end time when the current frame is processed, ma'am. So the processing time for the one frame will be time difference between the current time and the previous frame time, ma'am. So that we can accurately we can detect the lanes as much as easily, ma'am. This is what yeah we have did, ma'am. For like uh, this pandemic, we cannot do this project in using hardware. We just used only a software, ma'am. We have used the image processing technique to detect like the lane boundary lines. The proposed method which we have offered is good performance, but it has to be improved in order to adapt it with the bad weather condition, ma'am. Like especially in rainy conditions and even in bad light conditions, ma'am. In future work, we will try to detect the lanes and above all conditions, ma'am. Like we can um, uh, we can use hardwares like steps to I have only the methodology now to how to implement this in using the hardware systems. Like first of all, the camera module captures the image, ma'am, and image through CMOS image sensor, ma'am. The image sensor employed by most digital cameras in a change coupled devices, CCD, ma'am. And in some cameras, they'll use complementary metal oxide semiconductors, that is CMOS, ma'am. That is my own proposal, proposed to do like my own idea to do that in that way, ma'am. Like CMOS sensor. So both CCD and CMOS image sensors convert light into electrons, ma'am. Like both have different principles, but both have different principles, ma'am. once a sensor converts the light into electrons, it reads the value of each cell in the image. Like CCE transports the charge across the chip and reads it one corner of the array, and analog to digital converter (ADC) then turns each pixel reduced into a digital value by measuring the amount of charge at each photo site, and converting that measurement to binary form. In CMOS device uses several transmitters at each pixel to amplify and move the charge using more traditional wires. This is what I've studied in CMOS device. The image data will be after that. The image data will be converted into RGB, which we have seen in the software process. The same thing is followed in the hardware also, and then the image is converted to grayscale image to obtain the image intensity for detecting the lane. This whole process, whatever proposed now, is everything is processed in a single process by using the hardware called FPGA, FPGA chip, ma'am. The expansion is field programmable gate arrays, ma'am. The FPGAs are a programmable silicon chip within a collection of programmable logic blocks surrounded by input and output blocks that are put together through programmable interconnect resources to become any kind of digital circuit or a system. It is developed from the programmable read-only memory and programmable logic device now. So by using this FPGA, I can process up to the grayscale, whatever processed up to the K-means reduction, I can process in a single method, single hardware system, that is called FPGA, so that it will reduce the time. That is, FPGA hardware can greatly reduce the image capture processing time frame from 1 second to 10 milliseconds in comparison with software capture using the USB transmission. So this is what I'm gonna do in future work by using the hardware system.
Sudhir, done?
Yes, ma'am.
Where is your partner?
Ishwak.
Yes, ma'am.
Vishwak, what is your contribution?
Ma'am,
Vishwak, are you there?
Ishwak.
So yes, a team presentation. Every team member has to present. Okay. Sudhir, you said you're going to incorporate using FPGA.
Yes, ma'am.
Why it is particularly with FPGA? Why not with other processor board?
Ma'am, like FPGA can reduce more time, ma'am, from 1 second to 10 milliseconds, ma'am, by comparing with other things. It can reduce the data, like processing data, ma'am. Well, it will get the data from the live camera, ma'am. After that, it has to be displayed. It has to be displayed, ma'am. So that image processing should be reduced, ma'am. So that once a time is reduced, the output will be can get easily, ma'am.
For your single image processing, how much time it takes you to process it and complete it? For single recognition, how much time it has taken to complete it? Have you tracked it?
No, ma'am, I didn't track it, ma'am. But once, but while processing, it will take somewhat time, ma'am, by using this software. So by using this hardware, we can reduce some more time. That's what.
Yes, you should not say a generic word or a common word. It may or it will. Okay, but you should be specific. Yes, using this tool, I have identified the amount of time it consumes to processing it. Okay.
Yes, ma'am.
Okay, Sudhir, anything else you would like to share?
Nothing.
That's all?
That's all.
Okay. Okay, thank you, Sudhir.
Thank you. Thank you.
Next team. Navin Kumar. Drive Smart team.
Ma'am. Very visible, ma'am.
Yeah, it's visible.
Yes, it is visible.
Good afternoon, ma'am. My title is Dinesh. My project title is Smart Drive. With my friend, I am doing this project. Abstract. I don't have an abstract. Hello. Yeah, I'm an abstract of my project. Nowadays, number of vehicles increasing day by day, ma'am. Accidents also increasing rapidly. To order to reduce accidents, we are proposing this technology, ma'am. In introduction, can we move to introduction? I mean, introduction, most of the accidents happening due to overspeed, like or animals moving into a road. On that time, we should panic and we need to apply brake, but unfortunately, we are applying accelerator like that. We are doing and we hitting some animals or anything. On that time, we fix some sensors to car. When we start the car, the sensor also activated. And if you
Your
nearest to the
slides
any
are
car,
not visible. 1 minute. Your slides are not visible. Dinesh, can you see the slides in your monitor? Yeah.
yes,
Now
ma'am.
it is visible, but when you go for the presentation mode, I think it is not visible. Now
It's
press
visible
F5.
now.
Yeah. Go to F5. No, you press F5 for full screen.
Navin,
Otherwise, you proceed the same.
yeah. Like we fix some sensors to car. When we
Yeah. Now come to introduction. Yeah, good.
we fix some sensors to car, like when we start the car, sensor also activated. When we move to nearest to the some other car, like in front of the car, we are moving some kilometers per hour. We are very nearest to car. On the time, we give some message to driver, like you are moving so speed, like that. If he didn't activate like braking any applying. On that time, it's automatically applied brake and open airbags open. That I will move to another slide. Like these are the models including the system, ma'am, like radar, laser, is sensor, like camera, GPS, and AEBS means advanced emergency braking system. And Navin will say, ma'am, next slide.
Good afternoon, ma'am. This is Navin Kumar. In our smart drive system, we are using this radar sensors to detect the speed of the front vehicles, ma'am. When these radar signals are emitted, it travels away from the source, which we initially fix to the bumpers of the car, like this, until they strike the object, which is a targeted object. When the signals strike the object, they bounce back and travel towards the radar. After processing the signals, the radar detects the object, the position of the object, and direction and speed of the object. And these laser sensors will also help in the same way like the radar sensors. use these laser sensors to measure the distance between the our vehicle and the other vehicles to check whether we are maintaining the minimum distance between the vehicles. Using these cameras, we will identify the what type of object is nearing to us. This GPS will track the location of our car every instance, and when the car is entered into unsafe areas, like most of the accidents will happen particular areas, then it gives a signal to the driver that you entered into an unsafe area. This AEBS will take its own actions when the distance limit exceeds. Then it gives the information to the driver, and if the driver is not taking any action, it automatically takes its own actions and applies brakes in order to avoid the crashing with the other vehicles.
The smart drive system is also very useful to today's society now. It makes driver aware of their surroundings. It will be easier to avoid a collision to another car, anything, and he will concentrate on driving only. On that, we are giving some messages outputs when we are driving. We more concentrate on the road only now, on driving only. And Navin will present limited implementation.
When we start the car, automatically the sensor we already fixed to the car will be activated now, and it starts detecting the objects near to us.
It is not visible, ma. Yeah, now it's fine.
Okay. When we start the car, automatically the sensor will be activated now, and it starts detecting the objects near to us. And if any the sensor, it will pop up a message to the driver that vehicle is detected at a distance. And if the vehicle is moving at a high speed, using this radar sensor, detect the speed of the vehicle, and it shows a message that you are moving at a high speed in unrestricted areas. This GPS tracker will help the driver to give a message that if we entered into the unsafe area where accidents happen regularly, that you entered into an unsafe area. If the radar sensors detect the other vehicles, and if the driver is not controlling the brakes, that this AEBS will automatically apply the brakes and car will be locked. That's it.
Navin, Navin, why can't you display anything in the dashboard? Why you have shown everything in the debug monitor?
Ma'am, I displayed, ma'am. Wait, ma'am, I will show you, ma'am. I displayed in the dashboard, ma'am. I'll show you. When the sensors are activated, I'll connected this to HiveMQ, ma'am. You and the distance is not maintaining. It gives a message that for vehicle distance limit is exceeded. Your car will be locked. So, it displays GPS, used GPS to the dashboard mode.
Okay, Naveen, what is your future contribution? What will your future work?
When using the cameras, we cannot detect the object, what type of object at high speed, ma'am.
Okay.
So we have to change that, ma'am.
So how you are going to handle it?
Isn't I have no idea.
No idea. You have an idea to deploy it in the hardware, or you're planning to have it in the simulation alone?
No, ma'am, hardware, ma'am. But I am trying, ma'am, how to detect the objects at a high speed, ma'am. Still not a.
Okay, Naveen.
Thank you, ma'am.
Okay, thank you. If you like to say anything, you can do it. Else, we can give the thing to the next student.
Nothing, ma'am. Finished, ma'am.
Okay.
Thank you, ma'am.
Thank you, Naveen. Thank you. The next team, Tejasvi.
Yes, ma'am.
Yes, you can start.
Okay, ma'am. Is my screen visible, ma'am? Good morning, everyone. My project is about smart blind stick. So there are like many blind people who can't able to walk comfortably around the streets due to these obstacles around them. Like if there is any water pit or any obstacle, they can't able to walk, and then they might get hurt. So these basics help them to walk properly, and which direction also. So this blind stick is built on Arduino and have used the components audio, ultrasonic distance sensor, and piezo. Piezo is the buzzer which is used, and the resistor. Resistor is used for the current for giving the current for the certain components which are used, and the vibration motor and the potentiometer will help to control the range of the distance which the person can able to identify, and then relay. This is the block diagram of the proposed system. Due to the RF receiver and then the notification in on sorry the police can able to get the near the traffic light. The police can able to get the notification like the blind people, the blind person is waiting near the traffic light. So can you please help them? So this is the block diagram, and these are the modules which are used. The object detection module will by using the ultrasonic sensor, it can able to detect the obstacle. The computation model which helps integrate between the object detection module and then the output module, and then it helps to produce the sound and the vibration. Output module is alert sound and the vibration. There is a buzzer near the connected to the Arduino, and there is a communication module which helps the which is present on the strip, will help the traffic police to receive the information about the blind person. This is done in the tinker card, the stimulation of it. That's it, ma'am. This is the future work of the. That's it, ma'am.
Your demo?
Actually, I tried to integrate between the noted and the model to get the notification. So this is the thing I run, and this is the dashboard node now. I mean to give the information about the blind person and then register. If there is any emergency, there is an emergency button on the smart blind stick, so that if they can able to click on it and the information goes to the company or the nearby traffic police or around them. This is the dashboard. That's it now.
So have you tried communicating this to through email or SMS?
No, ma'am.
This looks very simple, right, Tejashvi? It looks a normal lab experiment, right, Tejashvi? You're going to do it for a project, right?
Yes, ma'am.
So what will be a future scope of this work?
So I'm like if there is any emergency or that I mean to display it on the screen, ma'am, nearby screen, so that the people around them can able to help them by person.
At least you would have included a voice text to voice conversion, right? It is they are blind people, so they could hear the voice, no?
Yes, ma'am. I will try to implement it.
Okay, Tejashvi.
Thank you, ma'am.
Okay. Next team, so you can join. Whoever is completed, you can join in the live and you can start voting for your friends. Next, Kavi Arison team.
Yes, ma'am.
Yes, Kavi Arison.
Ma'am, is my PPT visible now?
Not yet.
1 second.
Yes, it is about to start.
No, ma'am.
Yes, it is visible now.
My PPT, ma'am.
Yes, it is visible.
Okay, ma'am. Dashboard, ma'am. My project is power theft identification using Arduino. Dashboard, ma'am. So, power theft identification I chose because of it's a huge problem in India because it affects economically both government and the people. So, here's the project.
here are the sensors I have used. I have used current sensor and a relay and a display and an Arduino Nano and GSM module, ma'am. I used GSM module because if there is a power theft identified, it sends a message to the office or center to check whether the power theft is identified or not. So I'm using this one. This is my proposed system, and there are 4 sensors I'm using. 3 are connected to the poles and 1 is connected to the house. And it's connected to Arduino and both GSM and relay and LCD display. This is my working model, ma'am. C1 is the power supply, ma'am. C1, C2, C3, C4 are both 4 are current sensors, ma'am. C1 is a power supply and C2 and C4. These are in poles, ma'am. C3 current sensor is placed in the house, ma'am. There is a relay between the pole and the house, ma'am. When the current is theft or it can be identified by using, normally the power supply is from C1, ma'am. So C1 should be C2 plus C4, ma'am. Right, I'll show you. Equal to C3. Ma'am, C3 is sensor placed in the house. C2 is the sensor placed in the pole, ma'am. If it's not equal, there is a power theft in the house, ma'am. It's a power supply, ma'am. And if it is greater than C2 and C4, there is power theft from the pole, ma'am. Directly, some people trying to get the electricity from the pole by using some wires or other materials, ma'am. So this is my proposed model, and when the power theft is identified, the relay gets activated, and the GSM module sends a message to the office by specifically pole location, ma'am. By that they can identify easily which pole they identified. That's it, ma'am.
Pearson, you have demo?
Ma'am, I have tried using Tinkercad, ma'am. I didn't get it.